I wrote that down.
This is an example where f prime does not exist, and particularly x equals 0 in this case. So f prime at x equals 0, f prime does not exist at that point. Now, that would be a critical point. Like, look at it graphically. What would that be, a minimum or a maximum? A minimum. And these are extreme values. So this would be a minimum in this case. Now, very important side note, every extreme value does not necessarily mean it's a min or a max, whether local or not. We'll learn later in 4.3, there's another thing called inflection points, but don't worry about it. Just know not every point is a max or a min. And I forgot one more thing, also the endpoints. So where equation ends and begins, because I'm going to do it for an interval for now. Tomorrow we'll do without an interval, but for today we'll do it with an interval. So put down endpoints also. And then we have our question for our example right here. Endpoints in
where extreme values
could be found. It will also be at endpoints. Okay. Does that it?
No.
Extreme values, min or max are extreme values, but not every extreme value is a min or a max. It's called an inflection point, but I can't really describe it to you until we get to 4.3. Yeah. It would look kind of like this, though. If you want something like, oh, x cubed would have that. Look at this. X cubed, let me hear, would kind of look like this, right? At 0, the slope is 0. But notice, it is true, f prime of x at 3 at 0 would be 0. But it is not a max nor a min, because right of it, it goes up, and the left of it goes down. So sometimes you can have values like that. And that, an example, is an inflection point. Okay, so let's go through some problems. X squared from the interval of -1 to 27. X2 to the third power. X 2/3 power. Which, if you want to rewrite, cube root of x to the second power to help you visualize this. From the interval of -1 to 27, notice these are hard brackets, so it's including those endpoints. Okay, so let's go to the checklist of where endpoint or extreme points could exist. First off, where f of prime is 0. You can put it on this x too if you want. That's the same thing. So no. So let's talk about this. This is f of x. So what is f prime of x? So what's the derivative of x2 to the third? Or 2 divided by 3? Good. 2/3 x negative 1/3.
Or you could say 2/3 over. Wait, why are we finding the derivative?
Because we need to go through the checklist of things where our derivative could exist. So the first thing we're going to check is where f prime of x equals 0. So we need the f of prime. So let's set that up. 2/3, and I'll rewrite it as the cube root of x here.
Where did the interval points go into this? They're not like in the equation.
They're not in the equation. We'll do that. We'll do that at the end. So one candidate would be where this would equal 0. Now, is there any number I could plug into this that would cause it to be 0? No. There's no number I could plug in this to be cause 0. So we finish our first checkpoint. Let's check the next thing. F of x does not exist. In this equation, our original f of x equation, is there any part that we cannot plug into? Is there any number we can't plug into the cube root of x squared?
Where can you plug
In f of x, which was originally x 2 over 3, which is one of these two things. I just rewrote it though. Is there any restrictions on the domain? Like, is there anything that you can't plug in? No, there's no restrictions here. So we're going to the next part. Is there any restrictions in the f prime of x? So we already primed it over here. Is there anything here where I can't plug in a number? Or is there any number I can't plug in? What number can I not plug into? Because it will cost undefined. You can plug in -1 into cube root. Zero. You cannot plug in a 0 here because what would occur? 2 times 3 times 0, which would be 2 over 0, which is undefined. So that I know, but I'm explaining why it was. So 0, x equaling 0 is a candidate for an extreme point. X equals 0 is a candidate for an extreme point. The endpoints are automatically candidates. So x equaling -1 and x equaling 27.
Why did you make it equal to 0?
X is equal to 0.
The 2 over 3 times cube root of x equals 0.
That was my first test in red. But in green, I plugged in a 0, which caused it to be undefined. So I wanted to figure out where would it be undefined. And it happens to be when I put x equals 0. What? Yeah. What's your question? Yes, it is being recorded on Zoom. Sure. So x equals 0, x equals -1, x equals 27. Okay, so let's plug in these values. At x equals 0, what's up? Where did I get the x equals 0? Technically from the third thing, which I underlined in green, because f prime of x does not exist at 0. Okay? So x is 0, x of -1, and x of 27. So I'm going to plug in x of 0 into my original equation. 0 to the 2/3 powers is what? 0. So your first point is 0, 0.
Why are we plugging in 0 for the first one?
Because we figured out that 0 is going to be a critical point, and we're going to plug it in. Yeah. We're going to plug in -1 into the equation. So -1 into the x to the -2 to the 3rd power. That's why I rewrote it like this over here. -1 cube root is -1, and then -1 squared is 1. Original f of x. So x to the 2 over 3 power. All right, so 27, we're going to plug it in. What is the cube root? Okay, so either way, 27, the cube root of 27 is 3. And then you're going to square it. 3 squared is 9. So this is 27, 9. So these points right here, these points, these coordinate points, are your extreme values. But how do you know which points to plug in? Yeah, but I'm checking every possible point. So -1 comma and -27 are both also points.
Point is always going to be 0 because that's always going to get you some sort of undefined situation, or unless it's in a root that a negative would.
Yeah.
So like, okay.
But at that point, if it's like let's say it's a square root is a negative, then it wouldn't be continuous. And this rule only works if it is continuous.
So then it's always going to be, when would the third point not be zero?
X minus 4, all that squared.
Why?
Because then you would have, if you derive it, 2x minus 4 equals 0. And if you did the math, you're not going to get x equals 0 in that situation. Like I can make up a problem that where 0 is not the 1, but 0 is a good guess. Okay. Let's go to, where's my pen? Let's go to another example. Maybe this one will be more straightforward. We have a, not problem. We have a polynomial equation right here. Negative x to the third minus 3x squared minus 1. We got to check 3 points. Now, Tommy, you mentioned, why don't we just write negative 3 and 3 in the beginning? That's fine. X negative 3, x equals 3. Because those are endpoints. You know you're going to plug them in. So let's continue, though. We're going to try to find points.
How do we get
X negative x cubed minus 3x squared minus 1.
How did you get 1 for the y value when you put in x minus 1?
What's the cube root of negative 1? Okay, what is negative 1 squared? Okay, what's the cube root of positive 1? Yeah, that's why. Okay. Did that make sense? Or am I? Yeah, okay. All right, so first one, this is f of x. We're going to test where f prime of x equals 0. So what we're going to do is derive this equation. So somebody wants to give me the derivative of this equation? Go ahead, Jeff.
Negative 3x squared minus 6x.
Good, that's it. Yeah, you're right. So that's it. So negative 3x squared minus 6. Now, we want to figure out what x values cause it to be 0. So I'm going to factor this out, or I'm going to set it equal to 0 and then solve for it. And in order to solve for it, I'm going to factor. What can I factor out between 3x squared and negative 6x? What's up? Good. I'm going to factor out a negative 3x. What I'm left over with is an x plus 2 equaling 0. Okay. Then you split it. What's your 2 x's that are possible here? X equals, and x equals negative 2. So that joins the list of your extreme values. X equals 0, x equals negative 2. Okay. Go ahead. We're going to have 4 extreme values, yes. These are not roots. Make sure you know the difference. It's definitely not roots on the graph. Or not guaranteed to be roots on the graph. That's not necessarily true. Okay.
Now we have
Next one, we're going to check where does the function does not exist. It's a polynomial function. So is there any restrictions on what I could plug in here? No. So nothing we gain from that situation. There's no restrictions. I can plug in any number. I'm going to check where f of prime of x does not exist. No, we did f of x. So this original equation, we checked where it doesn't exist. This one, we did f of prime equals 0. So we're looking what gives you the value 0. Now we're looking at f of prime of x, it does not exist. So we're looking at this equation. Is there any issues with anything I plug in? Do I have any restrictions on the domain? No, so I don't gain another value from it. So from this point on, we have the 4 extreme values. X is equal to negative 3, x is 3, x is 0, x is negative 2. All 4 of these are extreme values.
You see all the way to the right, like the zero does not exist, does not exist.
Yes.
Do you have to write that?
No, I'm just writing that as a reference, but these are the things we're looking for when we're finding these values.
No, it's not that.
Hmm?
Do this all the time.
Now you can plug it back in, but that's algebra 1 skill, so I'm just going to go to the next question, okay? Because I just want to practice more examples of these things. I'll leave this in. Next one, e to the x squared from -2 to 2.
So -2.
So we can start off by putting the endpoints. -2 and x equals 2. Okay. So f of x equals ex to the squared. Does anyone want to give me what the derivative of this is?
EX squared.
Mm-hmm.
2x.
Good. So I'll put 2x ex squared. I'll write it like that order. Are you sure it's not the first one that's sitting on?
All right, Al.
Yeah.
If you eat it works if you like, lean back. So where is it?
Not all of them have.
Just use your hand.
Is your hand turn all of them? No, yeah, that.
That way, that way, down.
There you go.
Nice.
I feel like Max did not approve at all. I appreciate that, everyone. You can literally move your desk. Literally, we have more empty desks than full desks. Good. All right. So 2x e to the x squared. All right. Let's continue. Here, we're looking for where f of x would f prime of x equals 0. So in this situation, is there any situation that could cause this to be 0? We could split it up if we really want to, too.
It has to equal 0. It has to equal 0.
Good. So x equaling 0 is one of them. What's up?
3x squared multiplied by 2x, right?
It's
Not added?
it's multiplied. So it's 2x times ex. I just rewrote it the other way though. Now is ex squared? Is there any way to make that 0? ln? No. The fact is there any exponent can you plug in to make any number a 0?
1.
No, because 1 would just make it itself. So that would just be e.
Yeah, so
If you plugged in 0, it would be a 1, so that doesn't work. So there's no number that can make this work. So the only number that causes this to be 0 is x equals 0.
I did not.
Okay. In the original equation, is there anything that cannot exist here in the exponent? No, nothing is restricted. In the derivative, is there anything restricted? No. So so then we have our value points. Yeah, this one, 3. -2, 2, and 0.
The 0 just means that it makes it 0?
No, it just means at 0. Or are you asking why we picked x equals 0?
Yeah, like we need the whole function equal 0.
It made the derivative equal 0. Very important. Not the original function, but the derivative function 0. Okay?
No, what?
It
Like,
we're making f of prime equals 0.
always
Yeah.
for -2 and 2?
-2 and 2 are endpoints. So they get a free pass because they're just endpoints.
Okay.
And then 0 is chosen because it causes the prime or the derivative of ex squared to become 0. All right. More practice, or are we good today?
Good to
Okay.
All right. You guys on Zoom, you're free to go. Everyone have a wonderful day.